Hello guys, I'm gonna be doing a chemical magic tricks. Okay, chemical magic trick may sound a bit weird. In case you wonder why I say magic, well, I've seen many people doing magic tricks when I was young. I saw like somebody pour two colorless solutions into each other and then it turned into a yellow precipitation, and then they made a joke about a sunflower. And I remember someone poured a yellow solution into a colorless solution and then there was a red precipitation. They made a joke about some blood moon or something. And I remember, well, this is what I'm gonna show you. A blue solution mixed with a colorless solution and it formed a black precipitation. But I'm gonna add a little bit of explanation to that. So you see in here, I have some concentrated sodium hydroxide. When I say concentrated, I've measured the density, and the density is around like, I forgot, but the concentration is around 48%, so I assume that is concentrated. This, I don't know the concentration. Well, this is the most amount of copper sulfate I've managed to dissolve in a given solution, so I guess the max concentration I can reach at room temperature. This is copper sulfate solution, which is why you see it blue. The anhydrous copper sulfate is white, but dissolved in water, it reacts and then it becomes copper sulfate pentahydrate, which is blue. This is sulfuric acid. I am using dilute sulfuric acid because I don't want concentrated one. Concentrated sulfuric acid is really dehydrating, and if I ever contact it with my skin, I can suffer like some severe, I wouldn't say acid burns, more like, you know when you put sugar into concentrated sulfuric acid, it will form a black foam. I don't want the same fate happening to these hands. These hands are really precious. Right, now this is the testing. This I haven't labeled. I'll just pour the copper sulfate into this testing flask because I don't want to ruin the labels. And then you see this sodium hydroxide I'll pour into the copper sulfate. Now you see that there is some suspension. It's not fully reacting yet. Okay, but as you can see, there's a precipitation. I think I've added insufficient sodium hydroxide, so I think I should go collect some more. Give me a moment. Alright, just now you saw that there was insufficient sodium hydroxide because you see the solution is still slightly blue. So I collected a bit more and I dissolved in water. It's quite hot. I hope that's enough. So I would be pouring it into this copper sulfate solution. You can see that the precipitate is still blue. That's because some of the copper hydroxide haven't fully decomposed. I hope that they don't decompose, but it's inevitable for that to happen because they're not stable. I'll give it a good shake. So what happened is that the copper sulfate reacted with the sodium hydroxide to form copper hydroxide and sodium sulfate. So, which is why you can see the precipitate being copper hydroxide. Alright, now I think it's done. So you can see that this is a mixture of a black and blue suspension. The solution is supposed to be colorless because sodium sulfate has no color when it's dissolved in water. However, it's really hard to detect. I mean, I can prove it to show that a bit of the vapors are colorless, but vapors are not very reliable. I'm not going to bother doing the filtration because I'm too lazy to. So I should dissolve this using the sulfuric acid. I have a feeling I may not have enough sulfuric acid, but I should give it a try. Alright, before I get started, so just remember this is copper oxide and hydroxide. If I add sulfuric acid, it will form copper sulfate, and then the hydroxide will just react with the hydrogen ions to form water. So in the end, I should have a mixture of sodium sulfate and copper sulfate. This is dilute. Alright, let's get mixing. There's a little bit of bubbling. I'm not sure what they are. I assume some water vapors. The solution is quite hot though. Alright, you can see some of the precipitate is dissolving. I feel like I may not have added enough sulfuric acid. The thing is, I don't have a lot of sulfuric acid, so if I ever run out, I can instead resort to using sodium bisulfate. That also works, but it's way less efficient. You can see below that the precipitate is dissolving, but above there's still some precipitate left. So just give me a moment, I'll go collect some sodium bisulfate and I will dissolve all this precipitate. Alright, I've gotten my sodium bisulfate. You know, sodium bisulfate and sulfuric acid, they both work. I just don't want to waste my precious sulfuric acid. I'll add a handful of sodium bisulfate and I should dissolve this precipitate. You know, the beauty of a magic trick is that once you transform a substance into something else, you should always be able to change it back to its original. So, I think I've added a bit too much sodium bisulfate. You can see at the bottom. Doesn't matter if I added excess, as long as I can dissolve the black suspension into the blue solute. Now you can see that the copper oxide is slowly turning into copper sulfate. I should give it a good stirring to speed up this reaction because I'm an impatient person. You can see that below the sodium bisulfate is turning slightly blue. This shows that it is working. It will eventually dissolve. Okay, well, I can't stir it so much. My hands hurt. Just now when I added the sodium hydroxide, it was really hot because when I dissolve the sodium hydroxide flakes into water, it heats up a lot because it's highly exothermic. You can see that majority of the black precipitate has already dissolved. There are still some chunks left and I will not stop until all the chunks are dissolved. You can see that there's a little bit of steam being formed. I think I should add a little more sodium bisulfate. I feel like I did not add enough. I think that's enough, I hope. Well, I'm sure you would be a bit frustrated to see that not all the precipitate has dissolved. Well, I'm also a bit frustrated. Because to let all of it dissolve, I'll have to wait a while, but I'm sure that most of you all have low attention spans and can't be bothered watching a 10-minute video, so I'm having to try speed this up. But it's really difficult for me to speed up a reaction involving bisulfate because sodium bisulfate is much less efficient, which is why the reaction would be much slower than if I were to use concentrated sulfuric acid. But I don't want to use concentrated sulfuric acid. I want my hands to be alive. I don't want to lose my hands. I think I should add a little more to dissolve the few chunks of copper oxide that is remaining. Overall, I'd call this a success. As you can see, I've successfully done my chemical magic. So here's a breakdown. I've added copper sulfate solution to sodium hydroxide, which formed the blue solution to turn into a black precipitation. And then I dissolve the black precipitation by reacting it with sulfuric acid and sodium bisulfate, which will dissolve back into its original position, copper sulfate. So to simplify it, I basically turned copper sulfate into copper oxide, and then I turned it back to copper sulfate. Alright, now as you can see, all the black precipitation has dissolved. Well, what can you say? I just exposed one of the greatest magic tricks a chemist has made on stage. If you want, you can do this experiment at home. It's quite satisfying to watch. But keep in mind, when you're dissolving sodium hydroxide in water, you got to be really careful because it releases a lot of heat. And if that happens, you got to be cautious because, you know, sometimes if you add it to water, it can instantly start to boil, and you don't want sodium hydroxide to start splashing. So make sure you wear safety goggles when doing that. I don't want you to lose your eyes. And most importantly, I don't want myself to get blamed for what you are doing. Okay, there you have it. Thanks for watching. Please like and subscribe.